before you had a notebook, before printing presses, even before the idea of paper really existed, how did one of the world's greatest empires run things? I mean, for 3,000 years.
It's an amazing question. How do you track taxes or
Yeah.
huge building projects or, all your religious knowledge?
Exactly.
And the answer comes down to this simple swampy reed called papyrus.
Papyrus.
Yeah. If you look at civilizations nearby, like in Mesopotamia, they were using these heavy, really fragile clay tablets. Papyrus was a complete game changer.
How so?
Well, it was lightweight. You could roll it up, you could transport it. It allowed for quick daily administrative work that you just couldn't do with wet clay. It was a revolution.
So this material was kind of the secret ingredient that let Egypt grow from small kingdoms into this huge unified bureaucracy.
It really was. So today, let's trace the complete life of papyrus, from a plant growing in the Nile through all the complex engineering needed to make it, and then look at its legacy as the world's first major writing surface.
I like how you put it before we started, if the Egyptian kingdom was the hardware.
Then papyrus was the operating software. It's what kept everything running.
Okay, let's start at the source then. The plant itself, what is it?
It's a tall reed. It grows naturally, and tons of it, in the shallow waters of the Nile Delta. It has this kind of distinctive triangular stem, and it can grow several meters high.
So they had a massive renewable supply of it.
A huge supply. Farmers would just go out into the marshes, cut the stalks by hand, and bring them back to workshops that were always right there, near the river.
And proximity to the river was important.
It was critical. Water was fundamental to the entire process.
And you're now writing on the outside of the plant, right? The tough green skin?
No, you have to peel that away.
Uh-huh.
The real secret is the stuff inside. This white, spongy, fibrous material. It's called the pith.
The pith.
And the Egyptians were the first to figure out that this soft inner material, once you process it, is actually incredibly strong.
It's a huge leap, right? Taking what looks like stuffing and realizing you can keep records on it.
A massive leap. So once they had the pith exposed, workers used sharp bronze tools, basically knives, to slice it into these long, really thin strips.
And I imagine they had to be pretty precise with that.
Oh, precision was everything. If the strips were uneven, the final sheet would be bumpy, the writing would be blotchy, and you'd have just wasted all that work.
Wait, I have a question. If you're slicing up a wet plant, doesn't it start drying out right away?
That is a key point. You had to keep the strips totally soaked in water during this whole stage.
Why? Just to keep them from getting brittle.
That's part of it. But more importantly, the plant's natural sap was activated by the water. And that sap, well, that was the glue.
No way. So they didn't need to add glue.
Not yet. The plant provided its own bonding agent. It's this incredible piece of, early biomimicry. They used the plant's own biology to create the technology.
That's amazing. So once they have these thin, wet, sticky strips, what's next?
Well, now comes the real engineering. Turning those flimsy little pieces into a single, tough sheet.
And this is the layering technique, which I think is just brilliant.
It is. It's a very clever two-step process. They'd start by laying the first layer of strips vertically on a board or maybe a piece of cloth.
Okay.
Then right away, they'd lay a second layer horizontally, directly across the first. And the strips in both layers would overlap just a tiny bit.
That overlapping cross-grain design, that's the secret sauce, isn't it?
It is. It's the same basic principle we use in plywood today.
Right, because the grains are fighting each other at 90-degree angles. It makes it super strong.
Exactly. It creates this grid-like structure. So if you tried to rip a sheet of papyrus, you'd have to break fibers going in two different directions. It prevents a clean tear.
And because those strips are still wet with that natural sap?
Yes. As soon as they're layered, they need pressure. The whole wet sheet was placed under a massive weight. Sometimes a big stone slab, other times a mechanical press.
Well, how long?
Hours, sometimes even days. And this pressure squeezed out all the excess water and just fused the strips together.
And then after pressing, I assume you dry it.
You do, out of the hot Egyptian sun, which, not only finished the fusion process, but it also naturally bleached the material. It turned it into that thin, flexible, sort of yellowish sheet we all picture.
But it wasn't ready yet, right? I heard there was another step.
A very important one. The surface would still be rough, a little fuzzy almost,
Yeah.
and writing on that would be a disaster.
Right. It's like trying to write with a nice pen on a paper towel. The ink just bleeds everywhere.
Precisely. To stop that, they used smooth, rounded stones, or sometimes pieces of ivory, to painstakingly polish the surface. This compressed everything and created a smooth surface that stopped the ink from bleeding.
So you could get a nice crisp line.
A perfect crisp line. They usually polished both sides, but scribes almost always preferred to write on the side where the strips ran horizontally. It was just easier to write across than kind of fighting against the vertical grain.
So now you have a finished sheet, but what if you needed to write something long, like a history or a legal document?
You'd make a scroll. They would take these individual sheets and join them together, edge to edge.
With what? More sap?
No, this time they used a simple starch paste. Basically just flour and water. Simple glue.
Oh.
A standard roll for, say, administrative work might have about 20 sheets. But for huge religious texts like the Book of the Dead, you could have rolls stretching over 100 feet long.
100 feet. Wow. And I guess the scroll format makes it easy to transport. You just roll it up.
Exactly. Sometimes they'd attach a wooden rod to the end to make it easier to wind up.
Yeah.
But that created a big limitation.
What's that?
A scroll demands sequential access. To find something in the middle, you have to unroll the whole thing from the beginning. You can't just flip to a page like in a book.
Ah, okay. That makes sense. And the person who mastered all this technology was the scribe.
The scribe. And they weren't just workers. They were a highly respected, really powerful professional class. They controlled the information.
What were their tools like?
A very specific toolkit. Their pens were made from thin reeds, cut to a sharp point. And what's interesting is that some scribes would chew the end to fray the fibers, which turned the tip into a tiny little brush.
For the hieroglyphs.
For creating those thicker, more artistic strokes of hieroglyphics, yeah.
And the ink.
They kept it in these special palettes, usually with two little wells. The standard black ink was made from soot carbon mixed with water and a bit of gum to stabilize it.
And the second well.
That was for red ink. It was made from ground ochre, which is a natural earth pigment. Red was used for emphasis,
Yeah.
for titles, important headings, or marking, dangerous spells in magical texts.
So with this whole system in place, what were they actually writing down? It wasn't all just for giant monuments, was it?
Oh, not at all. Papyrus documented everything. Legal contracts, tax returns on the grain harvest, medical instructions, property records, even homework from students.
And for that, they used two different kinds of writing.
They had to. For religious texts or official monuments, stuff that was meant to last and look impressive, they used the detailed pictorial hieroglyphics. Beautiful, but incredibly slow to write.
And for the everyday stuff.
For the daily grind, scribes used hieratic.
Mm-hmm.
It was a simplified cursive script, a speedy, streamlined version of hieroglyphics that let them quickly calculate a harvest or write a receipt without drawing little pictures for every word.
So that speed was really the engine room of the Egyptian state.
Absolutely. The government's ability to track the population, manage resources across the entire country, mobilize workers for the pyramids, all of it was founded on these standardized mobile records made possible by papyrus.
And it didn't just stay in Egypt.
No, it became a global commodity. Because the plant grew so perfectly in the Nile Delta, Egypt had a near-total monopoly on its production.
Which gave them huge economic power.
Immense economic and geopolitical leverage. Papyrus was a hot commodity traded all across the Mediterranean. The Greeks, the Romans, they were all dependent on Egyptian papyrus for their own libraries and administrations. It was a strategic material, like oil is today.
So I bet they had some strict quality control.
They did. There were production standards. A standard sheet was often about 10 inches wide by 8 inches tall. And international buyers would inspect the rolls very carefully.
Were there different grades, like a premium version?
Oh, yeah. You could get very thin, delicate, beautifully polished papyrus. That was the premium stuff for luxury books or poetry.
And what about the cheaper stuff?
The heavier, coarser material, maybe not as well polished, that was the utility grade. It was used for receipts, temporary notes, or for students practicing their writing. A really sophisticated system.
But here's the paradox, right? It documented 3,000 years of history, but the material itself is actually really fragile.
Very fragile. It's organic. If you expose papyrus to dampness or humidity, it just decays, it dissolves.
So a lot of it is just gone.
That's why we have these huge gaps in the historical record. The documents that survive, the treasures we have today, only exist because they were stored in the super dry climate of the Egyptian desert, often in sealed ceramic jars or wooden boxes inside tombs.
So if it was so great, why did we stop using it? What replaced it?
It eventually lost out to parchment.
Which is made from animal skins.
Right. Parchment was more expensive to make, but it's way more durable. And most importantly, you could fold it down the middle without it cracking.
Ah, and that's the key. That ability to fold it?
That was the final nail in the coffin for the scroll. Once you could fold parchment sheets and bind them together, you create the codex.
What we call a book.
Exactly. And the book gives you instant, random access to any page. You don't have to unroll 50 feet of material to find one little passage. By the middle of the first millennium AD, the Codex had won.
And the secrets of making papyrus just faded away.
He did. But the legacy is undeniable.
I mean, we still use the English word paper comes directly from papyrus.
It does. This simple plant, transformed by some genius engineering, it preserved the world's first great literature and science and government.
It just shows that the greatness of a civilization can rest on these seemingly small inventions.
It does. The ability to turn a simple river reed into a standard, lightweight tool sustained the entire kingdom of ancient Egypt for thousands of years.
It's interesting. We rely on digital storage today and we think of it as permanent. But like you said, if papyrus was stored improperly, it literally turned to dust.
It vanished forever. So if we want our important knowledge to survive the next 5,000 years, we have to think really hard about how we're storing it. What current knowledge are we storing in a way that's maybe too fragile for the long march of time?
Something to think about. See you next time.